Welcome to today's webinar, AWS Infrastructure as Code, Best Practices with AWS CloudFormation. Our presenter today is Chris Munns. Chris is the Business Development Manager of DevOps at Amazon Web Services based in New York City. Chris works with AWS's customers to understand how DevOps culture, practices, and tools can help them to improve their organization's development and operation capabilities. Prior to this role, Chris spent a number of years gaining cloud operations and architecture experience as a solutions architect at AWS, as well as holding senior operations engineering posts at Etsy, Meetup, and Hinge. Today with us, we also have Dominic Divakaruni and Anil Kunar. They will serve as our webinar moderators and will engage with you and answer your questions throughout the presentation while Chris presents. Chris, welcome. The floor is now yours.
Chris, so today we're going to be talking a little bit about best practices AWS CloudFormation, some tips and tricks, and a little bit about the service. Again, please do ask your questions in the Q&A, and we will do our best to try to address those. One quick tip here, we will not be able to talk much today about roadmap items. Those are typically things that we only would share privately, so do understand that unfortunately we will not be able to answer those types of questions. Awesome, let's get started. So, light agenda for today, we'll talk a little bit about what CloudFormation is in case you are not familiar with it or maybe have not used it before. Then we'll dive into some of these best practices and recommendations that we have. We'll also talk about some key new features that recently launched in the service. And then again, at the end here, we'll try to do our best to address as many of your questions as we can. Again, a reminder that these slides and this recorded presentation will be made available to you shortly. And as always, if you have any further questions after today that we can't get to, we recommend that you go into our forums, email support, or reach out to your account management team if you happen to have an account manager. So AWS CloudFormation. Basically, essentially, with AWS CloudFormation, the idea that we have here is the ability for you to treat your infrastructure as code. You create template files that allow you to describe and model your AWS infrastructure. You then pass those into the service, which then go and provision the resources that you have declared inside of that file. Because it's a text-based file, you can actually version control this, you can replicate it, you can share it, and you can update it and treat your infrastructure again just like you would your own application code, which means that you can integrate this with development, continuous integration, and delivery workflows and other management tools. And CloudFormation is a free service that is provided at no additional cost. So again, essentially what happens is you create this file, this text-based file. We just launched YAML support, so that was new as of a couple of weeks ago. And previously we've had JSON support for the history of the service. So you write out this file, and we'll talk a little bit about the file structure here today. You pass it into the service, whether you're doing a stack creation or an update, and then what comes out of that is what we call a stack of resources. Now, a stack could potentially be a single resource or potentially dozens of resources that make up some component inside of your application or your infrastructure. So again, talking a little bit about this concept of treating your infrastructure as code, what that means is that there is a formal workflow to it, much like your own application. So we start with our code. We could pass it into version control. We could have somebody potentially review this. We could go through some sort of integration phase or step where we potentially deploy this into some sort of development environment. And then lastly, we could deploy this. And so the tools that one might use for this are the same ones that you would use for your application code today. Things like a text editor, some sort of version control service like Git or SVN or Perforce, or one of the many that are out there. There are various review tools that your team might use to review code and approve of it and validate it. You can then integrate it. So we have a number of tools that support the ability for things such as syntax checking, as well as the ability for you to take your templates and potentially promote them through different environments inside of your infrastructure. And then lastly, again, it's going to deploy those services for you. So again, in this case, it all is software, and you can think of it all as software. And because of that, it allows us to now treat our infrastructure as software in the way that we update it and interface with it. So with CloudFormation, we support the ability for you to do an in-place update of your infrastructure. So you can make changes to the template file, pass it back into the service, and it can either update existing resources or potentially replace them given the change that you're trying to apply. Another option that you have is that you can take that template file that you've just changed, launch a new stack with it, and then potentially do some sort of traffic shift, again, depending on what the resource is and where it might be lying inside of your infrastructure. And so there's obviously pros and cons that come along with this, but the great thing is that CloudFormation gives you the ability to model your updates or your deployments or whatever you want to consider it for the various resources, much like you would your own application code today. So this is an example of a template file. While I don't expect you to be able to read the small text here on this slide, what I do want you to get is the concept that there are a number of standardized sections to a CloudFormation template. So we have headers, parameters, mappings, conditionals, resources, and outputs. So I'll walk through here what these are all for. Header is pretty straightforward. This is the description of your stack. This is potentially a brief summary of the resources created, some other context that you might want to provide to the consumers of this template file if you share it inside of your organization, maybe a warning or a heads up on what cost might come from launching a template, lots of different things that you can do here. Next up you have parameters, which are provision time values that give you a bit of flexibility and customization to the resources that will be launched. And you can think of these as values that get passed in at execution time that then basically change the outcome of the stack's creation. Mappings then are a predefined conditional case statement. Essentially, this is a place where you will have, and we'll show some examples of this here in a bit, where you've predefined potentially different instance sizes, different AMIs, different components about your network, and it allows you to have this very nice matching up of a certain term to a certain resource attribute or identifier. Going along with this, then we have conditionals, and conditionals sometimes will interface with parameters and give you even more dynamic aspects to the stack that you're going to create. An example of this is we could have a parameter which maps to environments, and say we have dev, staging, prod. Based on that, in the conditionals, we can impact the way that our resources are launched across a number of different tools. Then we have resources. This is the real kind of meat of your stack here. This is the primary place that you'll be interfacing with. These are the AWS services and aspects and resources that you will be creating, such as EC2 instances, RDS databases, S3 buckets, etc. And then lastly, we have outputs. Outputs are a way for you to show and share the resulting attributes or resources from your stack. And so this is a great way for you to then, and we'll see later here, pass on attributes from one stack into another stack. Just a couple of quick examples here of some of the various components. This is an example here of an EC2 parameter. This is in the YAML format that we've had for the existence of CloudFormation. So we can see a couple of key areas about this resource. We have a description, we have then parameters. And inside here, the parameters, we have a number of pairings of things that would represent an EC2 instance, just like if you were launching this yourself in the web console. So for example here, we have the ability to specify the key name. We also have the ability, this is for parameters, my apologies. We have the ability for you to specify a key name. We have the ability for you to specify the instance type. So these are things that we're going to pass into the resource inside of our stack. We then can see here in this resource where we can have the attributes assigned. So these resources, again, would match up to just like what you would launch if you were launching from the console or the API or the command line tool. So we see here that we specified a key name, an image ID, and the instance type. And now we could have passed our resources attributes in from the parameters which we had just shown before. And we'll show some examples of that here as well. And then lastly, outputs. So outputs, again, are the way for you to share out the resulting information about the resources that's been created. For an example here, we've created a resource called Load Balancer, and what we want to do is share out the DNS name from this. So had this been an Elastic Load Balancer, which automatically has a DNS name created, that's what would be coming out of as this output. Great. So let's dive into some of the best practices here. And again, we're making a little bit of assumption that you might have some experience with CloudFormation, so we're not going to go too deep into the very basics here. We're going to dive into some of the best practices and patterns that we find are most valuable for people. So first one is that about a year ago, we launched a CloudFormation Designer. And so what CloudFormation Designer allows you to do is to visualize your template resources. You can either start out with an existing template or you could start with a blank clean slate, and it gives you the ability to drag and drop the resources that would exist inside of your template, connect them to various other resources that would be in relation to those, and then gives you the ability then to go and dive in onto the various attributes and aspects about those resources that you would want to configure. And so this ends up becoming a really great way for you to learn how CloudFormation templates are formed and what they look like, as well as being able to visualize your own. So you have a visual understanding of what your stack of resources is going to look like, again, from the designer's perspective. So working through the designer can be really, really impactful. Another really key best practice for CloudFormation is to only use CloudFormation. So when you launch and update resources with CloudFormation, it's able to track the changes that you've made over time. However, if you make changes outside of CloudFormation today, one of the challenges that we have is that CloudFormation doesn't have the ability to detect that change. And it has to do with partially the way that CloudFormation is, at the end of the day, itself an API client on top of other services, and so it's not necessarily reactive to those things today. And so you want to be aware of what those changes are. One of the things that can happen is that if you make a change to a resource outside of CloudFormation and then you update a CloudFormation stack, is that it could run into a conflict in terms of its understanding of where your resources are. So a real good best practice, and this is a general infrastructure best practice, is if you're treating your infrastructure as code, continue to use those infrastructure as code tools and methodologies as the primary way for updating and maintaining your infrastructure. Another great best practice is one that we launched, a feature that we launched earlier this year, which is change sets. So for those who may not be familiar with a change set can be both generated via taking an existing template and stack, updating it, and then essentially seeing what resources would be changed if you were to apply that update. The other is that you can treat a change set as its own atomic entity, if you will, that can then be applied across multiple stacks. And so makes it really easy in order for you to understand and see what would it be that might be impacted by me updating this template. What resources will change? How will they change? Will they be destroyed and replaced, or will they be just updated in place? And so this is a really great way in order for you to, again, understand exactly what's changing and then be able to use these change set resources as something that you store in maybe a ticketing system, as something that you review on your team as part of a code review process. And so there's a number of really great benefits to this. And so if you are using CloudFormation and you are updating templates and stacks, using change sets should become part of your day-to-day. Another best practice is one that people often miss initially, but eventually when you become very familiar with CloudFormation, again, becomes part of your day-to-day. So we have this concept of intrinsic functions inside of CloudFormation. These intrinsic functions support the ability for you to interface with both the template and the stack, as well as other resources inside of your AWS infrastructure. And so by using these, you can actually, again, make your templates more dynamic, and more capable of providing multiple solutions for you in a single template. So mappings, something I had talked about before and we didn't dive into much in the very beginning here. As you can see here, we have an example of a mapping that we're calling region map. So with region map, what we have is the regions listed, and then we also have the CPU architecture listed here. And it's not as easy to tell maybe just by the mapping, but that's what the 32 and the 64 represent. From there, what we have then is an AMI ID. So you could look at this and say that if I wanted the 64-bit AMI in US West 1, it's very easy for me to see the AMI ID that it is here, and that would be on the second line there, the AMI that ends in 78A. And so what you can do with this then is inside of a resource, you can actually refer to a mapping, and using one of these intrinsic functions, in this case we have fn find and map, and the intrinsic function is find and map, you'll see that we're referencing a region map. We're calling AWS region, which we'll talk about here in a moment. And then we're calling 32. We're passing in 32 for the 32-bit architecture. And so what this is going to do is it's going to populate this image ID, or the AMI ID, with the value that's found back in that mapping. And so this becomes a great way for you to have a number of kind of statically defined things like AMIs again, or security groups, or subnets, or other attributes about your resources that you would want to have given a template and be able to dynamically find it inside of the template at execution time. Another thing you can do with CloudFormation, and that's a very good recommendation from ours, is you can actually pass in EC2 user data into your CloudFormation template. And so we see here an example of us passing in that user data as essentially just a number of lines from a shell script. And so this will get executed the same as it would if you were passing it in any other way into an EC2 instance. But it makes it really easy to track inside of a CloudFormation template, doing it this way versus having it maybe be some sort of external thing that you paste into the EC2 console or that you pass in on the command line. But we can actually take it one step further. So inside of CloudFormation, we also have another tool called CloudFormation Init. And actually, it's part of a suite of tools that we have, or helper scripts, that allow you to manage EC2 instances at the OS level in terms of installing packages, signaling updates, a number of other things that you can do here. Well, CFN Init allows you to do is to read this metadata that you will pass into an instance, and then run a number of commands against that metadata to install packages, to configure your hosts, to do a number of different things. So what we see here is an example of what's possible to be passed into CFN Init today. So on the left here, you can see all the metadata options that we have. So we have packages, we have sources, we have commands, files, services, users, and groups. And then on the right-hand side here, you see an actual example of this. So I have an EC2 instance that I'm calling web app host. I have my metadata for CloudFormation Init. And inside of this, you can see that I'm calling the packages handler, and I'm going to use the yum command on this host to install a number of packages. And these packages would be potentially required to compiling code on this host. And so I can use this to do a whole bunch of configuration of my EC2 instances when they're first launched. And so again, based on the things that are in the left-hand column here in metadata, that's the places or the types of resources that I can impact on the OS and on the host itself. So bootstrapping your instances using CloudFormation, a really incredible, powerful part, I should say, of the service. Another best practice for CloudFormation is that we give you the ability to set stack policies that allow you to restrict or allow certain aspects of interfacing with the stack. We see here an example of a fairly straightforward policy. We're going to allow the ability for our user in this case to update anything about it. But then down below here, we're actually going to deny an update to a resource that we're calling production database. So production database would be the title of a resource inside of a template, and we're going to make it so that nobody can update that resource given this policy. And this could be a really important way for us to protect resources that we have from maybe accidentally being destroyed, being deleted, being modified in some way that might impact a running application. And so the way to get it to eventually change that resource would be to update the stack policy to allow that access, and then update it, and then reapply the stack policy. And so again, this gives you the ability to control through CloudFormation how people are modifying and updating those resources, but also understand that this only applies to those changes that come through CloudFormation. It still could be possible for someone to go into the console for production database, let's say it's an RDS instance, and make a change there. So again, this ties back to that best practice of only using CloudFormation to update the resources that we have over here in CloudFormation. And real quick, I see a question of does deny have precedence over allow? And it does actually, yes. So next up, we'll talk about ownership-based template design. So this is probably one of the most common questions that we get about CloudFormation is, where should the resources lie across the single or multiple templates? When should I potentially use nested stacks or use the new cross-reference capability that we have? And essentially, how should I think about this? So there's definitely a number of ways to solve this problem. But we'll talk about some of the general guidance that we have, and I'll try to answer some questions later on here about more specific aspects to this. One key one here is that we really want to think about limiting a template to a single service. Now, this is a generalized best practice, but you might have a time when you are regularly stamping out a number of services or applications or resource components as part of a stack. Let's say that maybe every developer in the organization is going to need the same set of resources in a development environment. That's something that you would want to combine. However, for a production environment, you might want to think about separate tiers of your application being in individual templates. You want to aim to have these templates be reusable across environments. I'll talk about this here a little bit more in a moment, but the idea that a single template should represent the multiple stages, or again, environments, whatever your term might be for this, of a resource. So if I'm going to launch something in development, testing, production in multiple regions perhaps, I don't want to have to create a template for each of those. I would want to have templates that would be generic across all of those. Again, we'll talk here in a moment about the usage of nested stacks as well as the new cross-stack reference capability that we have to break up large templates. And this is a really powerful way for you to think about how you compartmentalize your infrastructure and the various components that make it up. And then lastly, when it comes to things such as separation of roles and responsibilities, you can actually organize your templates along the structure or job function or even line of business that you have inside of your organization. For example, maybe you want to limit network resources such as VPCs, subnets, network ACLs to be only controlled by your networking team, but then you want your systems administrators to be able to launch EC2 consuming some of those resources. And then maybe you have a database team that's focused on, launching relational databases. So you can actually split up and organize your templates based on that functionality. So we see here a stack or a collection of resources. And so given this collection of resources, there's a number of different ways that we could represent this inside of CloudFormation. So thinking again about how this would live across various different environments, we really want to think about our single template being something that is multi-purpose and multifaceted across the various components of our infrastructure. So you want to take this template file, store it into some sort of version control system where we're tracking its changes and understanding how it's being modified and why. And then we want to be able to use this to deploy to dev, test, prod, etc. And this goes back to one of the key aspects of treating our infrastructure as code, is this capability and this idea that we have this trackable code resource, which is the template file, which can then be used to represent these various environments and stages that we have. And so again, building this type of dynamicness in using parameters, mappings, and conditionals is really one of the key aspects to using CloudFormation to the best of its capability. So going back here to our template that we have, so assume we have our template. It can represent, again, all the various stages that we have. This is an example of an entire template representing an entire infrastructure stack. And now this might be something that you want to do where you have it firing up all of these various resources, or it might be something where we want to split this up a little. So one thing that we can do is we can actually break up this larger environment into individual templates and individual stacks and make use of a concept called nested stacks. Now with nested stacks, what you think of it as essentially a layering mechanism, whereas you nest stacks on top of each other, and then the stacks that are, you can think of it as a parent-child relationship. The stacks that are child to a parent have the ability to reference the resources in that parent. And so this makes it very easy for us to set a core template or stack that represents, say, our virtual private cloud or some other aspects about our infrastructure, things like security groups, IAM roles, users profiles, etc., and then have just stacks on top of it that consume some of those. So instead of having to define subnets and network ACLs in my web layer here, I can actually just consume those from a lower layer. And so this makes it very easy for me to treat these various resources differently and to have a large-scale environment where I can delegate access to just certain templates or just certain components. There's another thing that we can do now, which is cross-stack references. So with cross-stack references, and we'll talk a little bit more about this here, you actually have the ability to consume the outputs from another template or another stack into a new stack that you're creating. And so this gives you a slightly looser tie between these various resources that would exist from stack to stack. And so why would you want to do this? There's a number of reasons. For one, when you do nested stacks, it can expose up all of the attributes and resources that exist at a lower level. You may not want to do that. You might want to have something where you only want to expose certain parameters or certain attributes up to other stacks. So that's one great thing about cross-stack references. The other is that it creates a slightly looser layering aspect in terms of how these are related to each other. So you still end up having a tight constraint, whereas you can't delete the resource that another stack is consuming. But in terms of how you interface with these and you think about things such as change sets, it becomes a different model here with cross-stack references versus nested stacks. So I had talked about reusability across environments. Another thing you want to think about is reusability across regions. So there's a number of different things that come into thinking about multi-region, and it can be something that you really want to spend an appropriate amount of time understanding and thinking about. So consider the differences that might exist between different regions inside of your account or inside of your usage of AWS. What resources lie in one, what resources might need to lie in another one. Things like EC2 image IDs, for example, or AMI IDs are specific to a given region. So you would need to potentially be creating those AMIs in different regions or copying those AMIs in different regions. And this is a great reason to use mappings inside of your infrastructure, or inside your templates, I should say. VPC environments. So in some regions, if you've been an AWS customer for a while, you might have what's called a classic environment or a non-VPC environment. So you want to be cognizant of, am I launching into a VPC or am I dealing with classic environments? And today we have ways for you to make it a lot easier to move towards VPC, which is something you should be doing. There's also the availability of instance types. So today, not every region has every instance type. And so you want to be cautious about where you're attempting to launch certain instance types, especially some of the newer instance types as we launch them. Are they available in all of the regions that you're trying to manage? IAM policy principles. So for your policies in IAM, are you doing anything region specific around account IDs, around service endpoints, things again that would be tied to a given region? There's also endpoint names. So thinking about what endpoint names you're giving people access to in IAM based on a given service. And then lastly, Amazon resource names often contain a given region. So if you're going to allow access between various resources, as an example, let's say that we were going to create a policy on a bucket and assign it to an IAM user, we often need to specify what region that resource lives in. And so hard coding that resource inside of a template would make that a problem for you as you go to update or create that stack in a different region. So think about how you can make all of these aspects reusable, how you can make them dynamic, again, making use of parameters, mappings, and conditionals to give you that really high flexibility in terms of these various resources. So another concept that we have here in CloudFormation is one of pseudo parameters. So there are a number of pseudo parameters that you can interface with to pull in things such as your account ID, the region that you're running this stack in, things like the stack name and ID. So then you can use those then to generate and to reference other aspects of your stack. So we see here that we have a bucket policy, and in this bucket policy, we're going to allow people to call the put object command against a given resource. In this case, the resource being a directory structure inside of a bucket. Now, we might want to use this template in multiple regions, or we might need to share this template across multiple accounts that we have for our business. So here we see bolded and kind of enlarged in the middle of the code here is a reference for AWS : account ID. So for any account that I run this inside of, it's going to go and replace that text with the account ID that exists. So you already mentioned the use of mappings, and this really is a best practice, again, giving you the ability to have very dynamic templates. Here we see another example where I have a regional config, we're calling it. And so we have a region, and then we have a number of aspects about a given resource that we might configure or that we're going to define inside of our template. So we see that we have predefined an AMI, we have predefined an ELB account ID, and then we have an ARN prefix, an ARN being an Amazon resource that we're going to define here. If you look on the right again in this bucket policy, we've taken our mapping and we've actually expanded it a little bit to pull in some of the various aspects about these mappings into the line for the resource ID. And so we can see that there is a function called join. It is then looking inside of the map to pull in from the mappings the various attributes that we're looking to pull in. Now, if we were running this in US East 1 or US West 1, this stack would, or this template would launch in both places without any problem, hopefully. Awesome. So that's mappings. Going back here again to conditionals, what we see here is an example of conditionals. So we have two conditions that are defined here. Is EC2 VPC or is EC2 Classic? And looking here again in the box on the left. If we look here inside the box on the left, what we're actually then looking for is if two different of our regions are defined, then we know that our infrastructure is running inside of a VPC. So if we're using EU Central 1 or we're using CN North 1, then we know that we have a VPC in those regions. However, if it's not one of those two regions, then we're going to say that it is actually an EC2 Classic. And so again, if we have our application spread across multiple regions, multiple environments, this could be something very important to how we launch and interface with our services. If we go over to the box on the right here, the code snippet, and we go down to the MySQL database resource, we actually then see where this conditional would be consumed. So inside of VPC security groups and then down below in DB security groups, essentially what we're saying is if this is inside of a VPC, use this one resource. If this is inside of EC2 Classic, not in a VPC, use this other one. And so this would give us the ability, again, to run this template in either of those environments without having to have a specific hard-coded environment exist for them. So in summary, we've gone over a number of best practices here. Use and look at the CloudFormation Designer to visualize and understand what your templates would look like from a logical perspective. Again, a great way to learn CloudFormation and to explore its capabilities. Avoid manual resource modification. So again, if you're going to use CloudFormation to update and manage resources, use only CloudFormation to update and manage resources. Preview your updates with change sets, so the ability to essentially see a differentiation between what exists now and what might be changed via an update to a template. Change sets should become part of your day-to-day workflow with CloudFormation. Learn the intrinsic functions. So we've seen a couple examples here of functions to look up mappings, to do joins, to do conditionals. These are all things that we want to be paying attention to, and again, add to the dynamicness of our templates. Use CloudFormation for bootstrapping. So it's a great way to get your instances from base AOS AMI up to something higher level and workable for you. You could use this to launch a higher level configuration management tool such as a Chef or a Puppet or maybe an Ansible or whatever you might want to be using, as well as to notify, say, other resources inside of your infrastructure that this host is up and running. So use either, again, the ability to pass in user data or potentially use the CFN init metadata to pass in the structured capabilities that it provides. Protect critical resources using stack policies. So because you have the ability now to treat your infrastructure as code and to templatize your infrastructure, you also have the ability to protect it. So applying stack policies around key resources inside of your infrastructure is a really great practice to follow and allows you to have kind of that higher level of assurance that the resources that are being treated as code are still being protected and respected at the right level. Think about how you're going to break up your templates for ownership-based template design. Again, there might be some reasons for using nested stacks. There might be some reasons for using cross-stack references. There might be some reasons for having all of your given resources inside of a single stack. For many of the customers that I work with, they actually use a little bit of all of these, depending on what the resource is, what the use case is, what the infrastructure component is. So become familiar with all of these. Understand that there is no one right way, but there are, again, those general guidelines for when you might choose one over the other. Plan for environment and multi-region support, right? So having a single template that could run across dev staging prod, across US East 1 and US West 1, or whatever region it might be, you want to try to minimize the number of templates that you have that are doing the same types of resource creation, and instead, again, lean upon mappings, conditionals, parameters, and so forth to make those templates much more useful. Lastly, make use of the pseudo parameters, the mappings, and conditionals that are available to you and that you can put inside of your template. Again, pseudo parameters give you the ability to have a parameter for things such as account IDs, region, stack names so that you don't have to hard code those things yourself. Mappings and conditionals give you the ability to have a number of different types of dynamic capabilities across your stack, and so do your best to make use of those so that, again, you're not either passing in too many parameters or hard coding too much inside of your templates. So now we'd like to talk to you about a couple of new features that we just recently launched. Technically, I guess it was 2 weeks ago that we launched these resources, or maybe last week now. Apologies for not remembering exact dates on this. So YAML formatted templates and then cross-stack references. So the first one here, YAML formatted templates. A big ask from you, our CloudFormation customers. We're really happy to bring it to you. YAML, very different structure, very different syntax from JSON. Some folks feel that it allows for better readability, for a better authoring experience. It does allow for native comment support, which is one key big aspect of YAML today. With JSON, you have to do it via metadata structures, a little bit more sophisticated. And then it also allows you to simplify your templates as things get more and more complex. So, versus JSON, where you have some of the brackets and a little number of more quotes and so forth, becomes a lot more of kind of unnecessary characters towards what you're trying to launch. So YAML will look and feel a lot simpler and a lot cleaner compared to JSON. And so we're really excited about getting this out to you, and we've gotten really fantastic feedback on it. So, the structure for YAML looks very similar to that of JSON in the most basic sense. What we see here is that the structure is done through indentation with YAML, whereas JSON is maybe a little bit looser about needing to worry about JSON, about spaces or tabs. Typically, you're dealing with spaces in YAML. Sequenced items are denoted by a dash. So we see here a dash for key name and value for tags. If we had multiples of these, there would be then multiple tags, multiple dashes listed below this. You see also here that key value pairs are separated by just a colon, so definitely a simplification from what we had with JSON. And then lastly, we recommend, just for readability, use a monospace font, don't use tabs, and save the file using UTF-8 or UTF-8 capable languages and fonts. So this ends up making, again, your templates much more readable, much more easy to diagnose and to kind of understand all of the resources and all of the capabilities that you're putting into that template. Still has the same structure as JSON, so we still have our headers, our parameters, our mappings, conditional resources and outputs, as well as metadata, which is something that JSON templates also supported. So there isn't a big change there. And for the most part, it should be very easy to translate those JSON templates into YAML. One big key change, though, in going from JSON to YAML is how we do intrinsic function declaration. We actually now have two different ways for you to declare intrinsic functions. There is a short form, as we call it, and a long form. So you'll see here in the short form, we have exclamation point find and map, and then we have the three values that we're passing in for the find and map function. In the long form, we're actually going to call fn : and then the function name, and then we're putting quotes around the terms that we're passing in. And it's important to note here that the exclamation point, which is often used in programming languages to denote a negative or a negation, in this case is not a negation. It is a way to declare a function inside of YAML. So this is a YAML specification. This isn't something that we ourselves came up with, but this is what you would need to do if you're going to go with the short form, potentially versus the long form, which may be a little bit more familiar to you if you're coming from having used CloudFormation with JSON for some period of time. A few things to note here with tags. So if you need to put functions together, you have to actually break them up like you see down here below on the bottom of the slide. So we can't do exclamation point base64, exclamation point sub, and so on. What we actually need to do is either potentially specify in the long form and then a colon short form, or pass in, like you see here, using square brackets around the other function that we're basically subbing inside of another one. So a little bit of a different way of dealing with the context here, but again, we're finding that this makes it much more simplistic over time. So here, real quick, is an example of some of the key intrinsic functions that you are typically using inside of CloudFormation and what they look like inside of this new YAML syntax version. I want to call out my favorite one down here on the bottom, which is function not, fn : not, which is often used as part of a conditional. So again, if you are coming from a traditional programming background where you're used to the exclamation point being a negative or a no or meaning the opposite of something, you could read the short form as not. But in this case, it's calling the actual function for not, which again is used in conditionals. So slight little change to the functionality here, but again, we feel that the YAML syntax versioning is, or the YAML document version, I should say, offers up a number of benefits. So as part of this, we actually are launching a new intrinsic function called sub. This allows you to substitute variables in an input string with values. And so these can come from a number of different places here. So this can accept either a string or a map as a parameter into it. So we can see here for some of the usage where I'm passing in var name and then my variable value. And then down below here, we actually have a literal value that we're passing in. So this would be the example of a string. You can also use a pipe. It's a little hard to see here in order to span multiple lines. So if we were passing in something longer like user data where it's going to take up multiple lines, this is where this pipe comes in. And now lastly, even though we launched this at the same time as YAML support, this is also available in JSON as well. So let's take a look at some examples here where this can be really useful. So what we have here is inside of what would have been, for the first example here, creating a file as part of the CFN init metadata that we'd be passing in. So we're creating a file called create-wp-config. And what we're going to do inside of this is we're going to be substituting inside of this text file these other parameter aspects that we'd be passing in. So we have db name, db user, and db password. And so this allows us to not have to say reference and pass in a bunch of other strings and characters, and instead it will just be included inside of this. And then if we go a little further down here, where we see this getting set up, we go down into the configure WordPress commands, we can see for some of these commands that will be executed that we are also passing in some of the variable functions or variable names that will relate back to values that have been passed in. So FN sub, we think, will help you simplify a lot of existing templates and then also give you a lot of other capability, again, to pass in values inside of things such as commands and other configuration aspects of your resources. Another feature that we just recently launched is cross-stack references. So previously you had to use nested stacks or potentially use a Lambda custom resource in order to pull resources or resource attributes from one stack into another, or potentially manually type it in as part of a parameter. In this case, what you can do is you can actually declare an explicit export of an output, and then we have another new function called import value that you can then use to import that value. So the way the cross-stack references work, again, is that you export this value from one stack to the rest of your account in a given region. So this value, you can think of it almost as kind of a global public variable, again, if you come from a development background, where you have the ability today for this exported output to be consumed by any other stack, again, unique within that region and that account. So if you go to launch a stack where you have another export name that you are trying to create, but it already exists, that will cause this stack to fail to launch or would cause a rollback if it was an existing stack. So it doesn't allow you to, again, double these up. The other thing that it will prevent you from doing is it will prevent you from deleting a stack that is consuming an exported value. So if you have fn import inside of a template from an exported variable in another template, you cannot delete either the resource or the stack that exported attribute comes from. So first you would have to stop using it, or you would have to update it to a different pointed attribute or asset, and then you could go and remove it. So it will give you kind of that safety net to prevent you from accidentally breaking some component of your infrastructure. So here is an example of using the function import value, again in JSON and YAML, and then down below for YAML we have both the long and the short way of declaring that function to be used. It's pretty straightforward. Again, we're just going to say import value, and then we're going to grab the global name that has been exported. And then we can see here an actual example of this. So in stack A, I'm exporting out the name of the security group for a certain security group that I have. And then in stack B, I'm actually going to import that value. So I'm going to apply that security group to the EC2 instance. And so again, not the same concept as nesting, but still gives us a similar capability, but with, again, these stacks being treated as kind of top tier stacks that are, again, sharing this resource. Okay, awesome. Well, thank you all for, again, joining us here today in this webinar and following along. We've covered a lot of things in a very short period of time. I see that there are a ton of awesome questions, so what I'm going to